Hi friends, here is a beautiful problem. We have to find five positive whole numbers, five different whole numbers, A, B, C, D, E, positive ones, right? Such that there is no subset with a sum divisible by five, right? We have to find five different numbers, A, B, C, D, E, such that if you, what is a subset? A, you can take any one or any combination of these numbers. And even if you pick any combination, that sum of those numbers should not be divisible by 5. Right? That is the problem. So, for example, if you randomly pick something, right? If you randomly pick numbers, it is, let's say, 1, 2, 3, 4, 5. Here, 5 is already divisible, so this doesn't work. So, let's pick something like 6. Right? Then, but again, 2 plus 3 is also divisible by 5, so this doesn't work. You can randomly try to pick any number. It becomes very difficult and it is impossible. Right? Whichever numbers you pick, there will always be some set within that, some subset where the sum of it is divisible by 5. Whichever ones you try. See, here 2 plus 3 is 5. If you instead of 3, if you put 7, right? Then also this 4 plus 6 is divisible by 5. Right. Instead of this, if you put let's say 8. Right. So then 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 1 is 15, which is divisible by 5. Right. So whichever numbers you take, it is impossible. Let's try to prove this also. How we can do that? Why that is happening? Let's take the same set A, B, C, D, E. Right, and let's take five subsets. A, B. These five subsets. A, B, C, A, B, C, D, and A, B, C, D, E. These five subsets. Right. Now let's take one random example also like this. So this is one. This is 1 comma 6. This is 1 6 11. This is 1 6 11 16. This is 1 6 11 16 17. Right. These are the five subsets. Any random detail. Now let's see clearly. Now this subset. What is the sum of this subset? It is 1. Here it is 7. Here it is 7 plus 11. What is 7 plus 11? 18. Right. Here it is this same 18 plus 16, which is 34. Here it is 34 plus 17, which is 51. Right. This is the sum of all of these numbers. Right. Now if you say if any set you take, if you divide it by 5, it will either leave a remainder 1 or 2 or 3 or 4. It cannot leave a remainder 5. Right. If it leaves a remainder 5, that means it is divisible by 5. Right. C, D, E. So it cannot leave a remainder 5. It cannot leave a remainder 0. Right. So that means if it leaves a remainder 5 or 0, that means it is divisible by 5. Our goal is, or we are saying that these sets, they are not, this set, whatever you take, nothing, this 5 will not divide this set. Right. This set is not, no subset is divisible by 5. That means the fifth set should also leave some remainder, which is either 1, 2, 3, 4. We don't know which is this. Right. So each set basically, each set, there will five sets, each set will leave remainder of 1, 2, 3, 4. Because there are five sets, there will be at least two sets which will leave the same remainder. Right? Because there are four choices of reminders. There are four slots of reminders. And there are five sets. Even in the best case, the first set takes this, second takes this, third set takes this, fourth set takes this. The fifth set should take one of these sets. It could be this, or it could be this, whatever. This is called pigeonhole principle. Pigeonhole principle. What does this say? If, let's say, if there are n holes, whatever. Let's say there are three holes and there are four pigeons. Right. Then each pigeon is entering a hole, let's say. Then there will be at least one hole which has more than one pigeon. Right? Because if the first three take this, the fourth one has to take at least two, one of these, right? So there will be at least one hole which has two pigeons. Right. So let's say instead of four, there are seven pigeons. There are seven pigeons. Then that means there will be at least one board which has three pigeons, right? First one, one, two, three, four, five, six. The seventh one should take one of these three holes only. So there will be at least one hole which has got three pigeons when there are seven pigeons, right? So now we have four slots and five subsets, right? Four slots of reminders and five subsets. Now there will be at least one subset or one slot where there will be two subsets. That means at least one set, two subsets, which will give the same remainder when divided by 5. Right. In this example, for example, first set is taking when divided by 5, it will leave a remainder 1. Right. Second set, that is 1 plus 6, 7. When divided by 5, it will leave a remainder 2. Here, 18 will leave a remainder 3. And here, 34 will leave a remainder 4 when divided by 5. This 51, obviously, it has to leave a remainder 1. So, in this case, the fifth one is matching with the first one. Right. When we have two sets that are leaving a remainder. Right. Then what does that mean? If A and A, B, C, D, E, they are leaving the same remainder. Right. A versus A, B, C, D, E. Please note this. A versus A, B, C, D, E, they are leaving the same remainder. Then what does that mean? A, B, C, D, E minus A. That means B, C, D, E. Right. The sum of B, C, D, E is a multiple of 5. Otherwise, then only it will leave this contribution of BCD is actually zero in terms of remainder. Right. BCD is not contributing. If it is contributing something, then the remainder will be higher. So the remainder when 5 divides this BCD is 0. That's why A is also 1. ABCD is also leaving remainder 1. Right. Because BCDE is a multiple of 5, then only A plus BCDE is still the remainder is 1. In this case, if you check A, BCDE, that is 6 plus 11 plus uh, 16 plus 17, right? What does this become? This becomes 50, right? Total is 51 and minus 1, right? So this becomes 50. Right. So in this case, see, BCDE is actually divisible by 5. Right. So this is the proof. Now, any set you take, there are five sets. There will always be two subsets which have the same remainder. Right. That means the one which is adding, which is addition, right? Which is addition. So bigger subset minus smaller subset. Whatever that is there, that is actually a subset which is divisible by 5. For example, A versus AB. A versus AB. If A and AB both are leaving a uh, remainder 1, let's say. For example, 1 and let's say 2 and 4. No, no. So 1 and not 2 and 4. 1 and 5 only. They both have to leave a remainder. What does that mean? Both remainder 6. Then that means B is actually divisible by 5. Right? When A is leaving a remainder 1 and the A plus B is also leaving a remainder 1, that means B is a multiple of 5. Right, guys? Hope you understood this. There will always be one subset, right? The subset is whatever is the difference of the subsets where the remainders are same. That subset is always a multiple of 5. It's always divisible by 5. Right, guys? Hope you understood this. This is a nice problem. This is a very important principle. We use it at multiple places. This pigeonhole principle. Right, guys? Thank you.